All right, gentlemen. Today we're going to look at the next part of our equation unit, which is equations that have no solution and infinite solution. So before we get into this topic, we're going to review some of the basic equations that we've seen and kind of see how it relates to this new idea. So here I have my first equation, 2x plus 1 equals 3, and I've modeled that 2x plus 1 equals 3. Now, hopefully at this point, this is one you could solve mentally, whether by doing inverse operations or just plugging in the number. So what number do you think x would have to be? Well, if you said 1, you're correct. You would take 1 off. That'd be 2. You divide it. X is 1. That makes sense. And there's no other number that you could plug in here besides 1 to make this true. 2 times 1 is 2, plus 1 is 3. No other number would make that true. Now, if I had this equation, it's a little different. 2x plus 1 equals 1. What do you think this x would have to be? Well, if you said 0, you're correct, because you could take 1 off of both sides. Now you have two x's balanced with nothing. Therefore, each x has to be nothing. X has to be 0. 2 times 0 is 0. 0 plus 1 is 1. That's a true statement. There's only one number you could plug in for x to make this equation true. This one, a little different. 2x plus 1 equals 0. This, again, is a fairly normal equation. You can take 1 off of both sides. Now, you might say, well, you can't take 1 off of 0. Yes, you can. If you take 1 from 0, you get negative 1. So I've taken off 1 of both sides. So I went from 0 to negative 1, and this went away. Now, you split this into two groups. You split 1 into two groups, and each x would be negative 1/2. So all I've done is I have done inverse operations. I subtracted 1 from both sides, and then I divided it by 2. X would be negative 1/2. And that's the only answer that works for this. Negative 1/2 times 2 is negative 1. Negative 1 plus 1 is 0. That is the only answer that you could plug in to make that true. So here I've had a regular whole number positive answer. Here I've had an answer where x equals 0. Here I've had an answer where x equals negative 1/2. These are all normal equations. What do you think this solution is? See if you can do this one in your head. All right. If you said x equals 5, you're right. You could take 2 x's off of both sides. X is 5. Again, another normal equation, and you have variables on both sides. And last normal equation. Now, this is distributive property. Some of you have seen this in GIM. This would be x plus 1, but then you have it twice. That's what that 2 outside of that means. 2 times the quantity x plus 1. And of course, another way to think about that is 2x plus 2, because you could distribute that. But in this case, it equals 6. So 2 times the quantity x plus 1 equals 6. What do you think x would have to be? All right. Well, what I did is I put these two together. I took this 2 off, made it a 4, and then I divided these into two groups. X equals 2. All right. So we have now seen these normal equations where you have one answer. So I'm going to write down here 2x plus 1 equals 3. That's a normal equation. We already solved this. X equaled 1. For this one, 2x plus 1 equals 0. We solved this one. 2x plus 1 equals 1. We solved this one. And we found out that x is 0. This one, 2x plus 1 equals 0. So it was a little trickier, but it was still x equals negative 1/2. We solved this one, 3x equals 2x plus 5. And we solved that. We got x equals 5. We did this one, 2 times the quantity x plus 1 equals 6. We solved this one, and we said x is 2. So now, let's look at what happens with an equation that looks like this. X plus 1 equals x plus 1. Well, if I build that, I have this. Well, if I start to solve this equation, maybe I would take 1 off both sides. But now I have an x on both sides. And if I do this, there's nothing left. There's no x's. X is gone. So I have nothing left. This is a strange situation. This has never happened where there's literally nothing left. There's no x's to solve for. So this is a weird equation. How do you solve this? This is the first example of these equations that either have no solution or infinite solution. Let's look at another example, see if you can start picking up a pattern here. This says x plus 1 plus x plus 3 equals 2x plus 4. Well, can anybody simplify this side? Could you rewrite this side? Instead of x plus 1 plus 3, how else could you write that? Well, you could also write it as 2x plus 4. And then if I took a 4 off of both sides, and then again, if I take 2 off of this side, 2 off of this side, everything is gone. So this, again, is kind of the same thing as this one, where literally everything goes away. How about this one? All right, now this is another distributive property. So what does this mean again? This means x plus 4, and there's 3 of them here. It says right, there's 3 of them. So x plus 4, x plus 4. And that equals 3x plus 12. We'll do maybe a 6 and a 6 here. All right. Well, 3x plus 12 is the same thing, or here, 3 groups of x plus 4 is really the same thing as 3x plus 12. 4 plus 4 plus 4 is 12. So if I take 12 off of this side, here's 12. Now, again, I'm going to take my x's, but again, all the x's go away. So we have the same thing. Even though these didn't even look the same, they wound up, everything just canceled out. Everything's gone. So again, we have this weird situation where sometimes all the variables and all the constants go away. Now, this one's going to act a little different. Let's see if you can figure out what's going to happen here. So here's x plus 1, and here's an x. All right, well, now in this case, there's really no 1 over here. So I'll take the x's off of both sides, and now I've never seen this before, where there's something left, but there's no x's. And I can't therefore solve for x. So this is an even weirder equation where there's a constant left, but there's no x's. You might say, well, you could take a 1 off of this side. Well, yeah, that's true. You could. And then you would have a negative 1 on this side, because 0 take away 1 would be negative 1. But it's still like there's no way to get rid of something. You can't get rid of this 1. I could add 1 to this side, okay, but then I have 1 over here. So there's this new idea that I can get rid of the x's, but sometimes I can't get rid of those green squares. Let's look at this one. This says x plus 1, x plus 1. There's 2 of them. And over here I have 2x plus 7. Well, I'm going to combine this to make 2x plus 2. And then I take away 2 from this side, and then this becomes a 5. Now I take 2 from both sides, and now I have just a 5 left, which again, sure, I'll take a 5 away from here, but now I have a negative 5 here. I add a 5, but then I have to add 5 here. So all the variables go away again. So now these are situations where all the x's disappear.